So today we're going to talk a little bit about parallel and perpendicular lines. Now, as you can see over on the right here, I have two lines that are parallel. In other words, two lines that will never touch. And what I want to do is I want to take a look at what is similar about these two lines other than the fact that they don't touch. Well, I'm going to take a look at their slopes. So here we go. Here's a point on that line, and here's another point on that line. And if I want to calculate a slope, I do my rise over my run from one point to another. So, in this case, I'll start from the bottom right, and I'll say if I go up and over, I can get a slope calculation from that. Now, where I'm going is I'm going from 1 all the way up to 7, so that's a rise of 6. And then I'm going all the way from 4 over to 0, so that's back 4. And if I calculate a slope here, my rise is 6, my run is -4, and that's going to take and reduce to a total of -3/2. Now let's look at the other line. I notice once again it goes through point here, and let's find another exact point that it goes through, right around here. And you'll notice if I go from one point to another, I go down this far and over this far. And you'll notice once again, I go from 1 down to -5, which is down 6, and move over from 0 to 4, which is 4. My slope, m, is equal to -6 over 4, which again reduces to -3 over 2. So what we found here is that the slopes of those two lines are exactly the same, and that's always going to be the case. In other words, parallel lines are always going to have the same slope, and that's a big concept. Now, let's take a look at another example. Here are two lines that are perpendicular, and again, I want to take a look at their slopes. So let's find a couple of points that this line goes exactly through. All right, and in this case, we see we have, let's go with this point here, and we'll go with this point here. And if I go down and over, you'll notice going down and over in this case, and it appears that we're going down 1 and over 5. So my slope for this line, m, is equal to -1/5 here. And then we've got to find another point that this line, another couple of points that this line goes exactly through. Let's try this one here. And let's go, I would say, and here's one here. So if I go up and over, then I notice I've gone up 5 and over 1. So this slope isn't quite the same. But you'll notice there's a similarity. I have a rise of 1 here and a run of 5, and here I have a rise of 5 and a run of 1. Also, you'll notice that the signs are opposite. This is no coincidence. Turns out that perpendicular lines have what are known as opposite reciprocal slopes. In other words, one's positive, one's negative, and then the two are reciprocals of each other. So once again, you see -1/5 and 5 over 1. So now we're going to do a series of problems involving these two concepts. First thing we're going to do is we're going to find the slope of a line parallel to a line of the following equation. So first of all, I'm going to have to find the slope of this line. And the easiest way to do that is put that in slope-intercept form. So what I'll do is I'll take and subtract 7x from both sides because we know we want to take and isolate our y term. So now I have 2y is equal to negative 7x plus 17. I'm going to divide both sides by 2, and y is equal to negative 7 over 2x plus 17 over 2. So what we're concerned about is we're concerned about our slope, and our slope is the number in front of the x term. And since we're asking to find the slope of a parallel line, we know parallel lines have the same slope, so the slope is equal to negative 7 over 2. Now, it says find the slope of a line perpendicular to the line in the problem above. And since we're talking about perpendicular, we need opposite reciprocal slopes. So the slope of this perpendicular line must have the opposite sign. Since this is negative, we must have a positive. And then we take the reciprocal of the two numbers. So that's 7 over 2. And that's the perpendicular slope. Once again, this is the parallel slope. We'll tack on a little more to this next problem. You want to write the equation of a line passing through the given point 1, 4 that's perpendicular to this line. Now, this line is already given to us in slope-intercept form. We know the slope is equal to 4/9. Now, we want a perpendicular. So our perpendicular slope is equal to the opposite reciprocal of 4/9. So that's negative 9 over 4. And therefore, we have an equation we can start writing. Y equals negative 9 over 4x plus whatever our y-intercept is, b. And we also know we have a point, x and y, made up of 1 and 4. So I'm going to substitute that back in. This is just like we've done with our finding the equation of a line, given a couple of points. We have 4 is equal to negative 9 over 4 times 1 plus b. I can get a common denominator if I like, since my denominator is 4 on this side. So what I'm going to do now is find a common denominator of 4. So 4 times 4 over 4, since I need my common denominator, is 16 over 4, equals to negative 9/4 plus b. I could have cleared a fraction too, but I'm just choosing to do it this way this time. I'll add 9/4 to both sides. And this is going to give me 25 over 4 is equal to b. So if I want to write the equation of my perpendicular line, that's y is equal to, I have negative 9/4 x plus 25 over 4. And that's it. Next, we're going to write the equation of a line passing through the point 7, negative 4 that's parallel to this line. Now, unfortunately, this time we don't have our line in slope-intercept form. So I'd like to do that. And what I'm going to do is I'm going to subtract 13 from both sides, and I'm going to add 6y to both sides. So what I have now is I have 5x minus 13 is equal to 6y. So what that gives us is 6y is equal to 5x minus 13. Divide both sides by 6. Giving us 5/6 x minus 13 over 6 is equal to y. If I want my slope, I look for the number in front of the x. This is my m, and my parallel m is going to be equal to the same thing because parallel lines have the same slope. So I can start an equation of y equals 5, 6 x plus b. And once again, I have an x value and a y value. And I'm going to go and plug those in. So I have negative 4 is equal to 5, 6 times 7 plus b. I have 35 over 6 plus b is equal to negative 4. And in this case, I'm going to multiply by 6 to both sides and clear the fraction. This gives me negative 24 is equal to 35 plus 6b. To solve b, I'll subtract 35 from both sides. This gives me 59 as a negative type. That's equal to 6b. Divide both sides by 6. So I get b equals negative 59 over 6. And thus, the equation of this line will be y equals 5, 6 x minus 59 over 6. Alright, lastly, here's a geometry type problem. In this quadrilateral or four-sided figure, we have diagonals AC and BD, and we want to determine if those are perpendicular and explain why. So if I'm going to determine if they're perpendicular, I need to show that their slopes are opposite reciprocals. So I'm going to take the slope of AC and calculate that. Well, if I rise from C to A and then run, it appears that I've gone up a total of 1, 2, 3, 4, 5, 6, 7, and over 1. So that's 7 over 1. And then I'm going to go rise over run. So I'm going to go up 1 and back. Let's do the counting. So we've got 1, 2, 3, 4, 5, 6, 7. So I rose 1 and went back 7, and that gave me the slope of BD. So since opposite reciprocal, then perpendicular.